Hello everyone! Today we will be talking about isopentyl acetate. This video has two parts. Part 1 is for this week and Part 2 is for next week. The aroma compounds present on this slide all have the same functional group in common, having an ester, which is circled here in purple. The ester group is what gives the compound a fruity smell. They are volatile compounds which can be perceived by the smell receptors in the olfactory tissues of the nasal cavity, and are generally of low molecular weight. Isopentyl acetate, which we will be synthesizing, has the familiar odor of a banana. Isobutyl formate smells like raspberries. N-propyl acetate is known for its characteristic odor of pears. Methylbutyrate has a fruity odor which resembles an apple or a pineapple. Let's move on to the next page to talk about the chemical reaction. Isopentyl acetate is synthesized by the direct esterification of acetic acid with isopentyl alcohol. Acetic acid contains an acid functional group, which is seen here in red. Isopentyl alcohol is an alcohol which contains the hydroxy functional group, which is seen here in dark blue. And isopentyl acetate contains an ester functional group, which is seen here in purple. So what does iso refer to? It refers to all the carbons that form a continuous chain except for one. We see this continuous chain in both the alcohol and in the ester, with this one carbon that is not in the continuous chain. What type of reaction is this? So it's a condensation reaction, which is a class of reactions in which two molecules combine, usually in the presence of a catalyst, with the elimination of water or some other simple molecule. The type of condensation that we will be doing is a dehydration reaction, which will eliminate water. The popular example which we will be doing is a Fischer esterification reaction. From this page, I'll begin to talk about the procedure of this lab for week 1. The first step of this reaction is heating to reflux. This is a technique that is frequently used in organic reactions by heating your compound to just above the boiling point for an extended period of time. The condenser, which is seen here, will cool the evaporated liquid and condense it, preventing the solvent from being lost. You should be able to see condensation forming. First, you'll need to assemble your reflux apparatus using a 25 milliliter round bottom flask and a water-cooled condenser. Also, use a heating mantle to heat your sample. Make sure that you set up your reflux apparatus with a stand and a clamp. Connect the water tap to the inlet at the bottom with a PVC clear tubing and connect the outlet at the top with PVC clear tubing and put the hose in the drain. Heat will increase the rate of the reaction, and the water-cooled condenser prevents the solvent vapors from escaping. After you set up the reflux apparatus, you will need to heat the reaction under reflux. First, determine the mass of a 10 milliliter graduated cylinder. Then add 5 milliliters of isopentyl alcohol and reweigh to determine the mass. Next, add alcohol to the round bottom flask. Then measure out 7 milliliters of glacial acetic acid and add that to the round bottom. Glacial acetic acid is in excess here, following Le Chatelier's principle. Then, by using a pipette, add 1 milliliter of sulfuric acid, which is concentrated, to a round bottom and swirl. Sulfuric acid is corrosive. It can cause severe burns to the skin and eyes, so handle it with extreme caution. If you get it on you, you want to wash it off immediately. Someone from your group should let the TA know as well. If it is on your clothes, you want to remove them so it doesn't stay in contact with your skin, furthering your burn. Then you'll add your boiling stone and attach the flask to the condenser with a cat clip. Heat the mixture to a boil, and once it's boiling, heat for an additional 75 minutes. As mentioned earlier, you'll heat your compound to just above the boiling point. You should see a reflux ring, which is condensation, about halfway up the condenser. If this ring is too high, you may lose vapor, and if it is too low, you may not be heating it enough, which will cause the reaction to not fully complete. After that, remove it from the heat and allow it to cool. Once your mixture has cooled, you are now able to perform a liquid-liquid extraction. You should be familiar with extractions from the caffeine lab. An extraction is when you're pulling out a desired species from one solvent to another, whereas washing is when you're removing impurities from a phase with your desired species. Today's case will be considered a wash. Set up a ring stand and obtain a beaker. You will use a separatory funnel. Make sure the stopcock is closed, or you will lose your crude product. You will then pour your solution into the separatory funnel. Add 10 milliliters of ice water and place the lid on. You will then gently shake your separatory funnel briefly and then vent. When venting, do it as seen here, with your separatory funnel pointed up and angled. Opening the stopcock slowly, this is going to relieve the pressure inside. When you're doing this, make sure you're doing it into a fume hood away from everyone else. The pressure that has built up can cause solutions to come out quickly. You will do this 3 times. Place the separatory funnel into the ring stand and allow the phases to separate. Your aqueous layer will be on the bottom, so drain that into a beaker. Next, add 5 milliliters of aqueous sodium bicarbonate. This is to remove any excess acid that is still present and neutralize the solution. It follows the chemical reaction seen here. Bicarbonate reacts with the excess acid that is still present and will form carbonic acid. The carbonic acid will decompose, which will form water and carbon dioxide gas. You will shake and vent the separatory funnel 3 times. Place in the ring stand and allow the layers to separate. Drain the aqueous layer into an aqueous beaker. Next, add 5 milliliters of aqueous sodium chloride to the separatory funnel. Shake and vent 3 times. Drain the aqueous layer into the aqueous waste beaker. The aqueous layer will be comprised of water. Unlike in the caffeine lab where aqueous layer was on top, it will be on the bottom layer this week because it is the less dense solvent. Now that you have your crude ester, you will transfer it to a clean 25 milliliter round bottom. You will then add drying agent to the round bottom until the clumps stop forming. The drying agent will combine with the water present in solution to form a solid or gel-like substance. The drying agent we'll be using is anhydrous sodium sulfate. You will likely need about 1 gram of this. Next, you will then cork the round bottom with a stopper and store it in your drawer until next week. You'll want to set it in a cork ring to keep it upright. The drying agent will be removed later. This half of the video will be for next week. We will be discussing the purification of your ester. Because your ester is a liquid, we will be performing a distillation. Distillations are used to separate 2 liquids from each other by heating a mixture of 2 liquids to the boiling point of the more volatile species. Since isopentyl alcohol and isopentyl acetate have different boiling points, they can be separated in this method, leaving you with pure product. Isopentyl alcohol's boiling point is 131 degrees Celsius, and isopentyl acetate's is 142 degrees Celsius. You'll be collecting purified isopentyl acetate. For distillations, you'll need a small round bottom to distill from, which will be your distilling flask. And that is to be clamped above a heating mantle. This will then be attached to a distillation adapter that you'll have a thermometer attached to. This will monitor the temperature. This all should be connected to the condenser. The condenser will be attached to a vacuum adapter that is clamped to another round bottom, which is your receiving flask. This should be pre-weighed to collect your product. Attach the PVC tubing as described in the reflex. First, you will decant your crude product from last week into a clean pre-weighed round bottom. Make sure you do not pour any of the drying agent into the round bottom. You will then assemble the distillation apparatus as described on the last slide. You will begin heating your sample to 140 degrees Celsius, which is the boiling point of isopentyl acetate. You will continue your distillation until only 1 or 2 drops of liquid remain in the distilling flask. You will need to record the boiling point range of your product. You will then be able to compare your experimental boiling point to the literature boiling point. You will need to weigh your product, subtracting how much your round bottom weighs to be left with your product's weight. This information should be recorded in your lab notebook. You will then be able to calculate the yield from this. To calculate the yield, you will need your actual mass that you just found divided by the theoretical mass that you calculated in the pre-lab. You'll multiply this by 100 to obtain the percent yield of your product. Record this in your notebook. Make sure you're using the correct significant figures. In this experiment, you will generate 3 types of waste: aqueous, organic, and solid waste. The aqueous waste will be comprised of saturated aqueous sodium bicarbonate, saturated aqueous sodium chloride, and water. This will go into a liquid aqueous waste jug. Your organic waste will be your ester product, which you will discard once you have obtained all the information necessary. This will go into a liquid organic waste jug. Lastly, you will have a solid waste, which will be your drying agent, sodium sulfate. This will go into the solid waste bucket. See you in the lab.